All right, this is a brief lesson on deductive reasoning. Okay, make sure that throughout this lesson you're taking notes, and you can pause it at any time throughout the lesson if you need to in order to copy the notes down. Okay, so don't forget that. That's the joy of looking at a video for a lesson, is that you can actually stop it, go back, and whatever it is you need to do. Okay, so here's a little taste of how deductive reasoning works. So, truth or myth? You shouldn't touch a baby bird because its mother will smell the human scent and disown it. Okay, I know I've definitely heard this one a lot. So, mom always told you, don't touch the baby bird. Its mama won't come or will disown it if you touch it. However, if I go over here to bluebirds across Nebraska, they have all kinds of wonderful information about bluebirds. And down here at the bottom, bluebird. Here we go. Do bluebirds have a sense of smell? Bluebirds and other passerines have a very poor sense of smell and taste compared to mammals, including man. This is often the reason why it is permissible to handle young birds while maintaining nests, or place a nestling back in the nest if they have fallen out. Though adult birds cannot detect the scent of human handling their young, as well as the fact that man and wild birds interact much more readily than most other wildlife. So, after you've read that, if we go back here to our conjecture here, so truth or myth, you shouldn't touch a baby bird because its mother will smell the human scent and disown it. Well, we just learned that the mother, the baby, or the bird really doesn't have that good of a sense of smell, can't smell humans, so this would be a myth. Okay, so that's just a little taste of what deductive reasoning looks like. Deductive reasoning is based on pretty solid fact. You read something, you make a conjecture, you go out, you find out something about it, and then based on those facts, you're able to come to a conclusion of that. Okay, so here is your definition of deductive reasoning. So you're following a path of logical steps to a conclusion. Okay, and this will often look like something with a lot of transition words in it. So you'll hear people say, well, I know this, and so therefore this will be happening, and so then I know that this will be the conclusion from that, and so because all of that is happening, I can conclude that, blah, blah, blah. Okay, so it has a nice linear kind of step pattern to it. So if we compare this to inductive reasoning, well, remember that inductive reasoning was more of just finding a pattern. It was kind of messy. You had to look at something and just had to try stuff, plug it in, see what works, what doesn't. And then after you'd put your hands in it and got dirty with it for a little while, then you were able to figure out, oh, okay, this is probably what's going on here, and you were able to make your conjecture, okay? Deductive reasoning is a lot more straightforward and linear. It's like saying, okay, here's this, now I know this, you're bringing in this fact, and now I can make this conclusion. Okay, so inductive reasoning, a little bit of a messier feel to it. It's a lot more of just finding a pattern. Deductive reasoning is based on facts. You're following them one fact to another until you reach a conclusion. Okay. All right, so here's an example of something that I can talk to you about with this. So if two segments are congruent, then they have the same length. And I am telling you that segment AB is congruent to segment XY. So if we have these two facts in front of us, two segments are congruent, they have the same length, and I just told you that these two segments are congruent to each other, we can conclude that those two segments have the same length. So remember, this notation here meant that segment, or the measure of segment AB, the length of segment AB, is equal to the length of segment XY, which is a reasonable conclusion based on our facts. Okay, here's another one. So if an animal is a mammal, then it has hair, and then if an animal is a dog, then it is a mammal. Okay, so this means if I have a dog, it's a mammal, and I know that if it's a mammal, then it has hair. So I think it is a very reasonable conclusion to say that if it's a dog, then it has hair. Okay, notice how we took this hypothesis here. So these are your conditional statements. We took this hypothesis and said, aha, to that hypothesis, there is this conclusion. And this conclusion, if it is a hypothesis, which is right up here, leads us to this conclusion. And so because these conclusions, hypothesis here, match up, then I can say, aha, then if I take this hypothesis, it is reasonable for me to reach this conclusion. Okay? So that's how your conditional statements can work for you in these cases. Okay. All right, so at this point you need to raise your hand and ask me for the homework. It is a Sudoku. For those of you who are not familiar with how to play Sudoku, let me go ahead and give you a little quick tutorial. Okay, so you'll look at something like this, and the whole idea with the Sudoku is that each column, so each column here, and then each row, and then each box has to have all the numbers 1 up to 9. So for example, in this box I have 1, I don't have 2, so I know that these 3 boxes here, one of them has to be 2. I have 3, I don't have 4 in this box, so one of them will have to be 4. 5, 6, I don't have 7, so one of them must be 7, and then 8, 9. Okay, so I know already that these 3 boxes will either have to be 2, 4, or 7. Okay, but I also look at the rows, and hey look, there's already a 2 in this row. So I can't put a 2 here, and I can't put a 2 here, because then that would make 2 2s in this row, and that is not acceptable. So that means that for this Sudoku, that's going to have to be our 2. Do you see how that works? Okay, let's do another one. So let's say, so I'm looking in this row or this column right here, and I have a 1, I have a 2, I don't have a 3, so this one or this one's going to have to be a 3. I have a 4, a 5, a 6, a 7. I don't have an 8, so one of these is going to have to be an 8. Okay, so it's either going to be a 3 or an 8. Well, if I look here, no, there's no 3 or 8 in this box, so we're good. There's no 3 or 8 in this row, we're good. So I don't really know if this is my 3 or my 8. Okay, let's go ahead and skip down though. Here, okay, there's no 3 or 8 in this box. There's no 3 or 8 in this row. I can't really make a conclusion here yet. So sometimes you'll run into that Sudokus. When that happens, you go ahead and just look at something else. Okay, so perhaps instead you would want to look over here in this box. And oh, this is kind of cool. Looky here. So 3 is in this row, so I know that 3 can't be either of those. 3 is in this row, so I know 3 can't be that one. So 3 must be one of these two, but look, 3 is in this column, so this one can't be 3, so that one's going to have to be 3. Aha! And so now, 1, 2, 3, 4, 5, 6, 7, so this one's going to have to be 8 to round out that column. Okay. Alright, so good luck with your Sudokus, and have a lovely time with inductive reasoning.